Yeah, they also give you a diagram, so that really helps. So I'm just reading out this one, and then let's solve this. Alright, in an inkjet printer, letters and images are created by squirting drops of ink horizontally at a sheet of paper from a rapidly moving nozzle. The pattern on the paper is controlled by an electrostatic valve that determines at each nozzle position whether the ink is squirted onto the paper or not. Here, the ink drops have a mass of 1 times 10 to the power of negative 11 kilograms each and leave the nozzle and travel horizontally towards the paper with a velocity of 25 meters per second. So here is the ink drop, and it is traveling that way at 25 meters per second, and the mass of the ink drop is 1 times 10 to the power of negative 11 kilograms. The drop then passes through a charging unit that gives each drop a positive charge of Q by causing it to lose some electrons. So, well, it has already gone through the charging unit, that's a nozzle, and then it's got the charge Q. So it's got the charge Q. The drop then passes between parallel deflecting plates of length 1.6 centimeters. So this is going to pass through. Alright, the drop then passes between parallel deflecting plates of length 1.6 centimeters. These are 1.6 centimeters. Where there is a uniform vertical electric field of magnitude E, which is 7.65 10 power 4. So the electric field, now this is a charge Q. They didn't say it is it's a positive charge. So this is a positive charge. And the electric field's direction they have not mentioned. Is it downward or upward is not mentioned. So you can actually take it whichever way you want. So if you take the field to be, say, upward, and the field is given to you as 7.65 10 power 4. 7.65 times 10 to the power of 4 Newton per coulomb. And the question is, if the drop is to be deflected by a distance d, which is 0.35 millimeters, by the time it reaches the end of the deflection plate. So by the time now, this is a positive charge and this is the field. Which way is it going to get deflected? This way or that way? That's a positive charge, that's a field. A positive charge will go with the field, and a negative charge will run against the field. Understand that part. I think I mentioned this, right? So a positive charge here, and the field is this way, so it has to be pushed that way. So while going forward, it's also getting pushed that way, so it ultimately goes like that. So this is basically what's happening. And by the time it goes 1.60 centimeters, it is going upward by 0.35 millimeters. Everything is given in 3 sig-figs, so we'll keep it all 3. Alright, so what magnitude of charge Q must be given to the drop? That's a question. Assume that the density of the ink drop is 1000 kilogram per meter cube. So the density of the ink drop is 1000 kilogram per meter cube. So if you look at it one way, yeah, this is basically a projectile motion problem. So think of the projectile motion that you learned last year. If you project something like this, just like that, so it's supposed to keep going horizontally with whatever velocity I pushed. But then because of gravity, it comes down. And I think here they say ignore the effects of gravity. So the gravitational effects on this, ignore. The only major effect is from the electric field. So what is pushing it that way vertically is the electric field pushing it. What is pushing it horizontally is nothing. It's just the initial velocity that's already given to it. So if you look at it that way, what is the force that is acting on the charge Q? So what is the force F on a charge Q in an electric field? QE. That is the force on a charge Q in an electric field. If that's the force, what's the acceleration? How do you get acceleration from force? Using F is equal to ma. QE over? That's the acceleration. And the acceleration is upward. Now, it's already go using the projectile motion approach. Horizontal, vertical. Try to recollect what we did last year. Let's say, what is the horizontal acceleration? 0. What is the vertical acceleration? QE over. That's a vertical acceleration. Obviously, you don't know Q and you don't know A. So the only things we know are these two. And then coming to what is the initial velocity horizontal? 25 meters per second. What is the displacement horizontal? 1.60 times 10 to the power of minus 2 meters. And so with this information, you should be able to get the time it takes for it to go from here to here. The time. Focus on this. What is the time equal to? You've done this last year. How do you get the time? Using projectile motion concept. This is how fast it's going, and this is how far it went. What's the time? That is correct. X over vi. And that will be 1.60 times 10 power minus 2 divided by velocity 25. Get the time. At least 3 seconds. How much?
I don't have a calculator.
Oh,
I got 6.4 times 10 to the negative 4.
exactly 6.4?
Yes.
40?
Yes. 6.40 times 10 to the negative
10 to the power of negative?
4.
That's the time. And you know, projectile motion, we transfer the time straight away here. And then the acceleration, oh no, not acceleration. What is the displacement here? Vertical displacement? 0.350 millimeters, which is basically 3.5 times 10 to the power of negative 4 meters. That is the displacement. That is a displacement. And what is the initial velocity? What is the initial vertical velocity? 0. So now we have 3 things here. This is known, this is known, this is known completely well. So you can find the acceleration, the value of the acceleration right there. And the equation of motion used is an equation which does not have VF. And so pick that up. X is equals to VIT plus half AT squared for vertical. VIT is 0 because VI is 0 vertically. And so here we have 3.5 times 10 to the power negative 4 is equal to half times A times T squared. That is 6.4 times 10 to the power minus 4 squared. Now find the acceleration. And once you have the acceleration, then you can plug it into this equation and then find the q, which is not known. That is basically how we do it. What is the acceleration? 1 point. Seven.
1.71 times 10 to the negative 11. That's what I got.
I don't think the power is right.
10 to the third.
What is that?
10 to the third.
10 to the third.
Wow.
That makes sense.
7.
Yeah.
Let me try this.
All right, so 1.71 times 10 power 3 meters per second square. That is the acceleration. Now all you do is pull things into that equation, and then here you have the answer. So you have 1.71 times 10 to the power of negative, times 10 power 3 is equal to Q, which is unknown. E is 7.65 times 10 to the power of 4 over mass, which is 1 times 10 to the power of negative 11. And so what is Q equal to? Q is going to be 1.71 times 10 to the power of 3 times 1 10 power negative 11 over 7.65 times 10 to the power of 4. Two point
2.28 times 10 to the negative 13.
2.28
Yes.
10 to the power of
Negative 13.
coulombs. Yep, so that is the answer. Well, 2.28 times 10 to the power negative 13. If it says express it to 3 sig figs, then you go there. If it is 2 sig figs, then put 3. All right, any questions on this? As you can see here, this thing is not used at all. So that's an information that was just given to you, but not needed. I don't know why they gave that. Probably to just mislead you. Well, if they give you the radius of this droplet, then you should be able to find the volume and use the density to find the mass. So instead of giving the mass, they give the radius. Then you will need this. Okay? Otherwise, you don't require it. They give the mass straight away, and that's what you need. You don't need the volume here. And they also say ignore gravity. You know why ignore gravity? Can you tell me why ignoring gravity is okay?
It's really small.
Because it's just 9.8. Look at the acceleration. Look at the electrical acceleration. 1,710 acceleration. And downward 9.8 is not going to make any difference. Very tiny. That's why they said ignore that part if it's not going to make a difference. And if you have to include that, then all that you do is subtract this with 9.8, and that's what's supposed to be good, the net acceleration. It won't change your answer significantly. All right, any questions on this? So first thing you should do is write down the data and the picture. And once you draw things up, then you don't have to look at the questions after that. You read the questions, please put everything down, and then after that you start working on it. Okay? Another one. I think there was another, yes.
Alright, you can go ahead.
There was another question which actually said there are 3 charges. There are 3 charges and the distance was given to you something. So the distance was given to you. So x, and you're supposed to find what is the strength of the electric field at this point, the fourth Cont, something like that. So to find the electric field there, well, what is to be done is find the electric field from this one at this. So what do you do to find the electric field? Put a unit positive charge over there. So put a unit positive charge over here. And find out how much force it experiences. That is the electric field. So the electric field from here is going to be this way, which is K Q times 1 over x squared. And the electric field from this one over here is going to be just the same value but upward, KQ over x squared. And the electric field from here is going to be that way. And that's going to be again KQ over this distance squared. This distance is actually radical 2 times x. So when you want this distance squared, you get 2x squared. Now we have all the electric fields. You have to find the resultant, and the angle is 45 degrees, you know that. So then go to your resolving stuff. So x, y component, x component. What is the x component of this? Oh, so you know what? I'm not going to use all this. I'm just going to call this P. Why do you carry all that stuff? Just take it as P. And take this as P. So it will be P over 2. And that is P again. So what is what is this field? It's P. P over 2. And so what is the x component of this? P. What is the y component of this? Nothing. What is the x component of this? 0 and P. What is the x component of this? It is P over 2 cosine 45. So P over 2 cosine 45. You know, cosine 45 is 1 over radical 2. So you put that here. It should come 0.3535 P. So this is what you're trying to do. So the answer is 0.3535. P is just 0.707 half of that. So P over 2 cosine 45. You can do it on your calculator, but this is what it is. So if you rationalize this, it becomes radical 2 over 2. So radical 2 is 1.414 divided by 4 gives you this. And this one is also identical. And both are positive, so 0.3535. Add them up. To find the resultant, just add them up. It will be P, 1P, and this is 1.3535P. And this also is 1.3535P. So the resultant components are identical, 1.3535P. 1.3535P. So that if you take the resultant of this, is going to be here. And that resultant is definitely at an angle of 45 because both are the same. So the resultant is going to be along the same line. How much is it? So you just have to find this resultant. So this square plus this square root. So what is 1.3535 square times 2? Square root of it. 1.3535 square plus 1.3535 square radical.
1.914.
1.914 P. That's your resultant. At this moment, you bring your numbers in. Until then, there's no need. You know, you just go with the. In fact, solving some of these problems is easier if you go with the variables only. Until the end. And then you substitute numbers. If you substitute numbers earlier, it appears to be a longer problem. Look at that. We got identical quantities and then we replaced with one letter and then we went on. So you got how many p's? It's 1.914 p. At this point, the resultant, you're going to take it as 1.914 p. And what is p? It's kq over x squared. So if you know the q and the x, substitute and get the result. Okay? All right? Again, a charge q is transferred from an initially uncharged plastic ball. So this is an initially uncharged plastic ball, and the charge q is going to be transferred to another one, which is also identical. So you're going to take q from here and drop it here. So what will happen to the charge of this? Both were neutral in the beginning. So if you take some charge from here and snatch it from here and put it here, so this is going to be charged. What about this? It's going to be oppositely charged, right? So if you're going to put q here, that's going to be minus q. Okay? So both were initially uncharged, but when you transfer some charge to the other one, this is going to become oppositely charged. But if you try to look into it again, why is it negatively charged? Because some electrons from here jumped into here. That's why. This is excess electrons. Okay? You don't take positive charges. You can't. It's the electrons that you can actually shuffle. So basically what's happening is, although I said take a charge from here and drop it there, okay, that is fine, but that is not what's happening. We're taking some electrons from here and dropping it here, thereby making this positive and this be negative. You understand? And the question finally is asking for the same thing. So, and the ball, they are actually 12 centimeters away. The force of attraction is then 17 millinewtons. These two are attracting each other by 17 millinewtons. They both attract each other with 17 millinewtons. Obviously, they have to attract because one is positive, one is negative. How many electrons were transferred from one ball to the other? So before you go to the electrons, you just find out the charge q. And they told you the force, they told you the distance. So what? Easy to find out this. So force is equal to kqq. The magnitude of the force is going to be this, divided by 0.12 squared. Take care of the units, very important. If something is given in grams, change it to milligrams, kilograms. If something is given in millimeters, change it to meters, centimeters to meters. So make sure those things are properly done. Many students actually do everything right way, but just keeping one unit. See those millinewton. Kind of easily taken as it is. So 17 millinewton is 17 times 10 to the power of negative 3. K is 9 times 10 to the power 9. Q squared over 0.12 squared. So tell me what is Q. Go ahead. What is Q? Punch the buttons and get it. 1.6
times 10.
Right? Now this is a charge. Now they're asking for the number of electrons transferred. So the connection between charge and electrons, well, the number of electrons times the electron charge is equal to Q. That's always the case. So the N is equal to Q over E. So all you do is 1.65 times 10 to the power of negative 7 divided by 1.6 times 10 to the power of negative 19. That will tell you how many electrons were actually removed from here and dropped here. Just 1 point. Something.
1.03.
1.03 times 10 to the power of
I have 12.
12 electrons. That's it. It's not a difficult problem at all. It's just one variety. Okay? Next question.
Mr. Sam, do you mind if I ask a question for the mastering?
Yeah, go ahead.
Okay. I don't have the mastering pulled up, but I have the diagram right here for you. It's kind of like an algebra one. They had
I'm going to do that.
okay.
I'm going to do that.
Thank you.
Yeah. The next one is this. Determine the direction and magnitude of the electric field at the point P shown in figure. The two charges are separated, so once they give you the figure, then they don't have to put too many words to describe what's happening. Right? But if they don't give a figure, it'll be pretty hard to express everything in words. So that's why they have to put so much into it. So if you see a figure, automatically, like you get more information from the figure itself. Okay? This problem actually also gives you the diagram, and I'll read the question after I draw the diagram. So there is a plus Q, and there is a minus Q. And this is at a distance A, and this is a midpoint. And at a distance of X, at this point, they're asking you to find the electric field. And the answer is supposed to be expressed only in K, Q, A, and X. You might have seen that. So determine the direction and magnitude of the electric field at the point P. In this figure, the two charges separated by a distance of 2a. You can see that separation is 2a. Point P is on the perpendicular bisector of the line joining the charges. This is a perpendicular bisector cutting into two. At a distance x from the midpoint between them. From the midpoint between them, this is x. And express your answers in these variables only. So for this, you need to find the electric field. So what is the electric field here? So what do you need to do to find the electric field? Bring a positive charge here, plus 1 coulomb. Bring a plus 1 coulomb and put it there. And then you discuss how much is the force experienced by this from this. That's positive. So what is this going to do to this? Repel. It'll repel in this direction. And what is the force going to be? It's KQ, so times 1 divided by this distance squared. So this is A and this is X. What is this?
A squared plus X, or radical A squared.
Radical A squared plus X squared. And of course you're going to square that. So it will be A squared plus X squared. So that's a field over there. And then what about this? This way. So the field is going to be this way. And that field and this field are actually the same. It's identical. So it's KQ over A squared plus X squared. So once you know this, look at the symmetry of things. Look at that symmetry. It's at the same angle. It's at the same angle. It's the same magnitude. So what will be the resultant of these two? Which way?
Straight down.
Straight down. So the resultant is going to be straight down. The resultant is going to be straight down. The resultant is going to be straight down. And now you want to find the magnitude of this result. Direction is clear, magnitude now. To find the magnitude, we again resolve it. Resolve it. This is horizontal, and that's vertical. Now, this one has a horizontal component in the negative direction. That one has a positive direction component. And since these angles are exactly the same, these two angles are the same. So this is same, this is same, this is same. Right? Since these angles are exactly the same, these two angles are exactly so. The component of this in this direction, the component of this in this direction, x components are going to cancel anyway. So I'm not even going to write things down here. Because the net force of these two in the x direction is 0. Right? So forget about it. In the y direction, this one has a component like that. That one has a component like that. Add them up, and that's what gives you this. So this one has a vertical component. That one has a similar vertical component. So basically now what you have to do is find this vertical component. Now to find the vertical component, you need this angle. And this angle is the same as this one. You see it? Because alpha plus theta is 90. Alpha plus theta is 90. So this angle is right there. So what is this component? KQ over a square plus x square cosine theta. And what about that one? That one has a component, but this vertical, and they're both negative, so downward. They're both downward, so both negative. What about the other one? Other one is also the same thing. KQ over a square plus x square cosine this angle, which is also theta. So what is the resultant of these two together? The resultant of those two together is 2kq over a square plus x square cosine theta. Now look at this triangle and tell me what is cosine theta.
It's negative.
It's negative, but I'm looking for the magnitude, so it's all right. We already know the direction is downwards, it's fine. Since we know both of them are downward, that's why the negative sign, but you don't have to bring the negative sign in, because they are asking what's the magnitude and what's the direction. You look for the main things. Negative sign need not be put in, because you're saying the direction is downward, so you don't have to put this minus sign. Okay, so ignore the minus sign right now. Because both of them are in the same direction downward, you times it by 2, and that's why I put the 2 there. What is cosine theta from this figure, from this triangle? Cosine of this is going to be adjacent over hypotenuse. So this becomes 2kq over a square plus x square. Cosine theta, which is a over radical a square plus x square. And the last step, 2kqa over, this is raised to the power of what? 1. This is raised to the power of what? This is a square plus x square to the power of 1, and that is a square plus x square to the power of half, radical. So joining them together, it is a square plus x square to the power of 3 over 2. That's it. That's your answer. I don't think you can simplify that any further. Okay? A point charge, mass 1 gram, at the end of an insulating string of length 55 centimeters is observed to be in equilibrium in a uniform horizontal electric field of 10,000 Newton per coulomb, when the pendulum's position is as shown in the figure. So I'll draw the figure. This is the pendulum. which is suspended, but then the pendulum is actually like that. It's 55 centimeters. The string is 55 centimeters long, and the mass of this is 1 gram. See, they said 55 centimeters, right? I immediately changed to meters. We don't want to like keep centimeters, and sometimes you forget. And then this m is the mass. It was given only 1 gram. I transferred it to kilograms. And they said there's a uniform electric field. And this thing is in equilibrium. Where was this pendulum before? This pendulum was here before. That pendulum was here before. Why was it in this position? Why was something hanging straight down?
Gravity.
Because gravity is pulling it down, that's why. But now, it is pushed that way. And it's a point charge, so it has a charge. It has a charge. And they say there was an electric field of 10,000 Newton per Coulomb applied, and the electric field that can push it that way is applied like that. And that is 10,000 Newton per Coulomb. 10,000 Newton per Coulomb is the electric field. And they say that when it went that way, in the figure it says it got raised by a distance of 12 centimeters. It went up 12 centimeters. I guess I can leave this in meters, centimeters, and then if needed we'll convert it. 55 centimeters, and that is 12 centimeters. And the question is, if the field points to the right, determine the magnitude and the sign of the positive charge, of the point charge. Sign. Sign means is it positive, is it negative? Now, electric field is this way, and as soon as the electric field is applied, it swings that way. So, is it a positive or negative charge? Positive. So, you already know the sign. It is a positive charge. Now they're asking you what is the magnitude of that charge. So basically you need to find the charge. So at this point there was only one force acting on it. What are the forces acting here? Gravity is acting for sure. So there is a gravitational force acting straight down. There's a gravitational force acting straight down, which is mg. And the other force that is acting on it is the electric field. The force due to the electric field, how much is it? In terms of E. QE. So we have QE acting that way and mg acting downward. Is there any other force acting on it? Tension. So there's a tension acting on it in this direction. And if this is at an angle theta, this tension is also at the same angle theta here. Okay. Not everything is given in the problem, it's just the position. All the blue things are given in the problem. But whatever I'm doing right now is additions we are putting into it so that we can understand better. Alright. So that's basically the problem, and this is to be worked out. So this point charge that is here is in equilibrium. What does it mean? The net force on it is 0. Since we know the net force is 0, horizontal, vertical. Each one has components, right? And when you add them all up, it's supposed to be 0. Because it is not moving, it is staying in that position, it is in equilibrium, which means all the components in the x direction, the horizontal direction, should add up to 0. All the components in the vertical direction should also add up to 0. The total force is 0. Go ahead, T. I told you this. If you are feeling, get up, stand. So let's go to one by one. What is the horizontal component of this? QE, all of it. What's the vertical component of this? Now let's go to this. What is the horizontal component of this? And what is the vertical component of this? Is it mg? The vertical component of this? Negative mg. It's downward. Now this one. What is the horizontal component of this? Horizontal component is this component, or this one. T sine theta. It is, what did I say, horizontal component? Backward. So negative T sine theta. Right. And this will be what? This component, which is a positive component of T cosine theta. And adding these, it's supposed to come out 0, and adding those, it should come out to be 0. So I'm going to add them up. QE minus T sine theta is equal to 0. So we get T sine theta is equal to 0. Now the last one there says minus mg plus T sine theta, cosine theta is equal to 0. So what is T cosine theta? Right? So we have T cosine theta is mg, T sine theta is, oh, why are you keeping quiet? T sine theta is equal to QE. Alright, so we have T cosine theta is mg and T sine theta is equal to QE, and now we need to get rid of the T. So if you put that equation here, T cosine theta is equal to mg, how do you get rid of the T? I have two equations. Alex. I have two equations. T sine theta is equal to QE, T cosine theta is equal to mg. How do you get rid of T? So what do you do? These are two equations. What do you do? Say that again. Take this square and add them up. That will get rid of the theta. But T will stay. What he is telling is, take the square of this and then add it to the square of this. That will be QE square plus mg square. But then what happens here is T square times sine square theta plus cos square theta, which is 1. So we finally end up with T, which we don't want. We don't know anything about T, and I don't want in the problem. So how do you get rid of the T? We have two equations. How do you get rid of the T? This is straightforward, yeah. And set it equal to each other. You have an equation. It's not just this. Yeah. I don't want the theta is something we can find out from there, because they give you some numbers. We can use that. I'm asking what you can do to this equation to get rid of T. Yeah. You just divide the first equation with the second equation. You divide it. When you divide it, see, you should know this. If you want to get rid of the theta, what he said is the right method. Square this and add them up. And then you'll see that magically the theta is gone. Sine square theta plus cos square theta is 1. And then T will remain in that case. But when you divide, T and T cancel. What is sine over cosine? So you have tangent of theta is equal to QE over mg. Now we have almost come to the final stages. We know E, we know G, we know M. If you can get to know this, then we can find G. So let's go to this picture now. You can see this is 12 centimeters. That is 12 centimeters, which means this is 12 centimeters. So do you have an idea what this is?
43 centimeters.
That's 43 centimeters. Now you know this is 43 and this is 55. Can you find this out? Trigonometry. Alright, so you know this is 43 and this is 55 and this is theta. So what ratio will connect these two? Cosine. So cosine of theta is equal to 43 over 55. And so what is theta equal to?
38.57.
38.57. So 38.6 degrees. Now that you know 38.6 degrees, put the tan. So here is your equation. Tan of 38.6 is equal to Q times 10,000 over mass, which is 1 times 10 power negative 3 times G, which is 9.81. If you work all this out, you will be able to solve for Q. Work that out and check if the answer is 7.8 10 power minus 7. 7.8 times 10 power negative 7 coulombs. That's supposed to be the answer. So check this out on your calculator and see if the answer is there. Okay?